Welcome everyone. Thank you for joining us today for this special webinar hosted by Factina and AWS. My name is Prasad and I'm part of customer success team here at Factina. And today in this webinar, we are going to discuss about maximizing asset efficiency with APM and CMMS on AWS. With us today in our panel, we have a special guest from AWS, Mr. Kailash Pooja, who is a solution architect in AWS, and Mr. Hariharan Ganesh, who is a founder and chief architect of Factina. So without further ado, let me hand over to Mr. Kailash to start the webinar. Over to you, Mr. Kailash.
Thank you very much. Hello, everyone. Good evening. This is Kailash Oza. I am a solution architect based out of Mumbai. And today we are going to take you through how you can use APM and CMMS to actually maximize your asset efficiencies. So with that, we'll just quickly move to agenda slide. So this is the broad agenda that we are going to cover in today's session. So we'll start with industry challenges and how APM can be used to solve those challenges. Then we would move to AWS APM framework. So in case you starting an APM journey, right? How AWS and AWS partner can help you quickly take this APM journey, quickly build and deploy solution on AWS cloud. So we'll talk about that. Then we will give you some customer examples, the customers who have how they're benefiting by using APM. Then I will hand it over to Factina team to talk about their solutions around APM and CMMS. So with that, let me start with an asset performance management. So as you know, right, all the asset intensive and asset heavy industry, they depend a lot on assets. And assets is very, very critical to their business operations. One of the key objective or one of the key criteria that they look for is to ensure that their assets is always performing well to give you the required throughput, right? So they need to take care about how well they maintain their assets, how well they do assessment, right? Integrity assessment about the assets, how well they are taking care about the safety compliance of their assets to ensure, they get a true value from their assets. And to do that, actually, they've got a lot of processes. And for each process, there are a lot of strategies to optimize those processes, right? So even if you talk about, say, maintenance, right? There are different ways to maintain an assets, right? And depending on actually what you want to achieve and how critical is your assets, you would take an appropriate asset strategy. And APM is all about help you optimize all the strategies. So with that, we will start with the typical challenges, right? And that an APM can help solve for manufacturing customers. The first one is if you talk about a lot of these companies, right, who are into an asset heavy industry, one of the key problem that they face is they've got limited visibility into their asset health. And the reason is actually multifold, right? So first, actually, they don't have those data from the assets available for them to actually really pick into and visibility into their assets. The second is even if the data is available, the data is a bit old, right? So they get data, they get historical data, which could be days older, right? The third problem, what they're seeing is the time it takes to really analyze this data is really cumbersome. And because of all this problem, typically they don't have a right strategy around whether you call maintenance or you call about, say, inspection or you call about safety, right? Because the critical piece, right? The critical piece is that is data, and having the data available at right time would really able to optimize on all these processes. So the bigger pain point that they have is they don't have the availability of right data. They don't have the capability to get this data available on real-time basis, and because of that, they are not able to really have a right strategy in place. And because of that, they're also not only actually they don't have right maintenance and integrity or reliability strategy, but even they struggle when it comes to meeting the compliance standard or regulatory demands from the government or regulatory bodies. The last point is s- uh, if you talk about all these different industries, right? They typically have hundreds of assets deployed, or maybe thousands of assets deployed across multiple plants. Now, the amount of data that they get out of these assets is very, very humongous, is very huge. The problem that they face is they really want to have a solution which can, help them collect, store, analyze, and visualize this data through some sort of an solution which can really make these things very, very easy. And because of that, they typically need a data-driven approach where which works something like very, very dynamic rather than static, right? Static is something where the data is not available, right? Or you haven't got historical data, but instead of historical data, the data-driven approach enables this organization to have a dynamic data. Okay. And the moment you have dynamic data, then you get an ability, right? Ability to drive a lot of outcome from this data. And that is where actually you would get a real-time visibility. That's the first thing. And then actually you can build a lot of use cases around it. So use cases in terms of you can start predicting the asset's health, right? Or you can start predicting the issue with your asset, right? And the moment actually you start predicting your asset failures, then it gives you an ability to control or eliminate those failures, right? Because you then taken corrective action in time. And then because you taken corrective action on time, actually it can result into multiple other benefits. So APM in nutshell, actually, it allows you to, if you look at this figure, right, and if you look at the complete asset life cycle, starting from say acquire to dispose, right? APM typically plays a role in, uh, sorry, just give me, plays a role in how you operate and maintain your assets. This is a critical area where APM can give you maximum benefit. And as we discussed, right, APM is a tool, but it needs to have an people expertise along with an streamlined processes supporting it to be successful in the organization. And once you have gotten successful APM implementation, APM actually can give you tactical benefits in terms of asset life, in terms of having a right maintenance strategy, managing your downtime, reducing a spare part inventory. But it can also link this tactical benefit to your business goals. So ultimately, you would be able to optimize your return on assets. And if you have got right and healthy assets, ultimately you would deliver right product at right time to your customer, which would increase your customer experience. It can link to your business benefit, and the employee can be more and more productive because a lot of the hard work, right, can be taken care by your APM solutions, and then employee can actually spend their time in productive activities. And based on what we have seen, right, based on what we have seen from our customer discussions, plus actually based on various market research, what we have seen is an effective APM implementation can ultimately result into 5 to 15% increase equipment lifetime, right? That means actually it can increase the lifetime of your equipment, which is very, very costly, right? So take an example: if your equipment is running for 10 years, if you haven't right optimized strategy, the life can be increased from 10 to say 12 to 13 years. Correct. The second benefit is an effective APM can help you in environment, health, and sustainability concerns, right? It can help you optimize your energy. It can actually help you reduce the safety incident. It can also help you in optimizing or actually reducing the carbon footprint. So it can really help you in your EHS concerns. It can also do a proper APM driven and maintenance strategy, right? Which could be, say, reliability centered or risk based maintenance, can ultimately help you reduce your maintenance cost and inspection cost, because it will allow you to only do maintenance when it is required. It's not a time based or schedule based maintenance, but it will exactly tell you based on the condition of the asset whether you need a maintenance activity or not. So it will really optimize your maintenance strategy and ultimately help you reduce your maintenance cost. It can also have a great impact on your spare parts, right? If you're able to predict a failure, when a failure is going to happen, right? Now, since you know what is the fault that is developing in your asset, based on the fault analysis, right, you can actually then order your spare parts rather than actually keeping those spare parts, which maybe an optimized way to or maybe actually can have a higher inventory cost, right? So it can really tell you when to order your spare parts, which can reduce your spare part cost. It can also ultimately, if you optimize all this, all if you look at all these factors, right, ultimately it will help you in decreasing your capex by 5 to 30%. So these are the potential benefits that an APM can bring to an organization, and that's the reason actually we have seen a lot of customers are talking about implementing an effective taking an effective APM journey so that they can leverage these benefits. Now we will switch a little bit, and we will just focus around if you really want to start this journey on either APM or CMMS, how AWS can help, right? So in AWS, we have a framework which we call AWS Framework for Industrial Solutions. Now, this framework can be very well used to build your APM solutions. So you got two different approaches. Either actually, if you're a builder organization, you can build your complete APM or AMR or maybe say CMMS solution on AWS Cloud, or you may actually through a partner, right? You can directly buy the solution off the shelf. The solution can be hosted on AWS Cloud. So both these approaches are available depending on your need. Actually, you can take the right approach. But if you want to build it right, so what we offer is, if you look at the bottom of the slide, these are the different data sources. From there, you would get in all the assets data, correct? So the asset data could be part of your SCADA, it could be part of a historian, it could be in MES. So wherever it may be, AWS gives you an ability to extend AWS cloud to your shop floor, to your plant, right? So part of AWS cloud can run within your factory premises, right? And that is where we give something like our edge capabilities, where you can run, say, green grass, where you can run site-wise, or you can run lambdas. So this gives you an ability to quickly talk to these different data sources, take the data out from these data sources, and then actually do um, some sort of a data processing on the edge itself. Now, this edge would actually sit across your plant. So you're planning to implement APM, say, across 10 plants. So you would have 10 different edges, right? Where you would run a local AWS services, which will talk to the plant specific data sources. It will get the data. It will do some sort of processing. And if required, the action can be taken on your plant itself rather than sending the data to the cloud, right? So take an example, you are working on a use case where safety is you're actually monitoring safety incidents, right? So safety incidents are very, very critical, right? So instead of taking something to the cloud, making a decision could be very, very may not be the right. Safety incident has to be detected at very low latency, right? So in that case, actually, you can use edge to detect those incidents, and then once you do that, actually, the data can be sent to the cloud. So in cloud, we've got to give you multiple options. So either you can use time series database, you can use industrial data lake, you can use data warehouse to store your data. And then once you store your data, the next important thing is the data has to be contextualized, right? Now, when your assets are doing or manufacturing your product, right? It is important to know, right? What was the my temperature reading? What was my say current signature when so and so product was getting manufactured? Or what is this? If you get data from certain asset, what is the location of the assets, right? So all this different thing has to be contextualized along with the actual time series data or the tag value of the machine that you are getting from your assets. So it will give you the building block that can be used to um, enrich or contextualize your data. And then ultimately what you need is you need some sort of a very, very specialized Lego building blocks or services to really act on the data. It could be simple reporting. It could be running your model on top of the data. You may want to build some sort of an digital twin out of this data, right? So then those services can be used, and ultimately, if you combine everything together, right, ultimately you would able to deliver an application which can be consumed by your the end user. It could be an asset performance management. It could be an asset maintenance and reliability. It could be CMMS. Whatever you want to build, the framework is available which can be used to build and deliver your applications very, very quickly. We also offer some sort of a maturity framework. The reason actually we do that, because what we have heard from a lot of our customer is the one of the key thing what they want to do is before they start an APM journey, right? They just wanted to do a quick assessment in terms of understanding their current benchmark, where they are in the APM journey. And that is where actually we give this framework. So this framework has got 5 different stages, and broadly we have divided this into a basic APM. So stage 1 is nothing but a basic APM, where you have all the asset taxonomies in place. You have got asset classification done. You're doing time-based inspections. So those are part of your basic APM. Stage 2 and stage 3 we call an intermediate APM, where what you do is typically you build on top of your stage 1 and you start doing an specific maintenance strategy for your different types of assets. So based on the asset criticality, based on the type of the fault that an asset can have, you have a localized maintenance strategy depending on a group of assets, right? And you start doing condition-based monitoring in stage 2 and 3. In stage 4, typically what you do is you start using an AI/ML, where you start not only detecting, but you start preventing your failures. You start eliminating your failure. You start predicting it when your asset is going to fail, right? You are doing some sort of an remaining useful life. All those capabilities come as part of stage 4. And stage 5, which will take you towards a prescriptive maintenance or prescriptive guidance, where what you do is you not only detect failure, but you actually guide your team what to do, right? You give a very, very prescriptive guidance in terms of how to fix an issue. So this is different levels of maturity models, and typically we are really happy to come and do this assessment for your organization. Typically, it's a 2 to 3 weeks engagement per plant, and as part of engagement, we assess your maturity. And then what we do is actually we also based on your business goals and your requirement, we define a to be state, and then actually we define a roadmap how actually you can move from an to be state to an from an as state to an to be state. So we can do all those things in all these activities in 2 to 3 weeks. So we're happy to engage with you and do this assessment for your team. As you must have heard, right, we're talking a lot about Industry 5.0. We're talking about maintenance 5.0. We're talking about reliability 5.0, right? One of the key element is having an APM capabilities, right, baked into all of this, all of your strategies, right? So what we call is a next gen APM. So next gen APM would really play a very key role in enabling Industry 5.0 or say maintenance 5.0. So what does the next gen APM delivers, right? The next gen APM is really built on latest, technology building blocks. So it not only uses an industrial IoT or say analytics, but it really uses AI/ML and generative AI, right? It actually uses digital twin. So digital twin can be used for building an dynamic twin of your physical assets, right? Which can help you not only give the real-time view, real-time health or detecting anomalies, but it can also allows you to do an what if kind of scenario simulations, right? Which can really, you can leverage it to really do a lot of simulations around risk, simulations around the health of your assets or your failure predictions, right? So those simulations can be carried out using digital twin. Another thing you can use is augmented reality, which is again something which would really help simplifies a lot of APM activities, because when you typically carry out and maintenance, the augmented reality 3D view can really make your technician very, very productive by giving them different views about different components and the inner working of those different assets and components. It can also enable remote collaborations, right? When somebody is working on fixing your assets, actually they can collaborate remotely through some other technicians. So in nutshell, technology would play a pivotal role in enabling next gen APM. Along with that, what we see is the APM is really actually holistically combining a lot of different processes together. So if you talk about say reliability centered maintenance, or if you talk about say compliance and asset compliance and integrity management, right? So all these different strategies would be seamlessly integrated using APM tool, and it will give you an ability to dynamically optimize all the strategies, because it will give you a real time view about how the asset strategies are performing, and in case something is not working well, actually you can immediately take an action and optimize those strategies, right? And ultimately what it will do is it will able to not only integrate with the core APM modules, but actually it will integrate with your enterprise assets management and other ERP tools, right? So which will give you a holistic view around the complete uh, your asset management needs. So that is one. And what I also want to do is, before actually I want to hand over to the partner team, I just wanted to also cover a few case studies. I will quickly take you through these case studies. So this is one where actually we have done it for one of our customer called Cepsa. So they are into multiple different domains, and the problem that they were facing is about scale. So they've got around 350,000 sensors. They've got 150 million data points per day, 1,000 terabyte of storage. What they wanted to do is they wanted to manage this data very, very well, right? They wanted a scale where the data can be easily managed. They wanted a compute where the data can be quickly analyzed and give them the required insight. That is where actually they chose AWS Cloud to build all the digital use cases around APM. Right, so that was one. The second case study was is from another customer from energy sector. So they use APM, and it was again what they wanted to do is they wanted to focus on two different aspects. One was increasing the energy, optimizing the energy consumption, and other was lowering lower throughput. Right. So they were trying to solve this problem. So how to reduce the energy consumption and how to increase the throughput. They leverage AWS partner solution to actually really solve these problems. And what they were able to ultimately do is they were able to increase 8% in efficiency, right? And they were able to increase 4% in asset lifetime by ensuring optimal assets rotations. So this was some of the case studies that I wanted to cover. With that, actually, what I will do is I will head it over to Factana team to cover the solutions that they have, and also take you through the demo about the Fogwing. I hand it back to you, Prasad.
Thank you, Kailash, for this informative information. I will hand it over to Hari for the demo of the software.
Hello, everyone. Good evening. Kailash, thank you so much for carrying forward on this. So I'm going to talk about now how do we practically implement APM solution, and how do we what is it we should take it up as approach to quickly realize the value of the APM and CMS solutions. As Kailash was talking about, customer can prefer to go with the build versus pre-built solution. So we are coming into that second part of that, where we can help the customer to rapidly implement the solution as per the AWS guidelines, and also to quickly realize the start seeing the data coming into the system, and start seeing the data analysis, especially asset health and performance data can be easily analyzed within the system. So rapid deployment standpoint, we help the customer using our solutions. Um, carry forwarding from what Kailash presented on the AWS in the industrial framework. So we take that as a core model. So to follow the same standard mechanism in implementing either build or buy. Customer should have the same standard framework as followed as per the guidelines from AWS. So we took that model, and we added up the data sets in the bottom layer, where you can see there different type of data that we capture from the assets, in terms of the location, energy, runtime, downtime, also the usage level, health parameters, production data in terms of what quantity and how things are being produced, and some of the health parameter like vibration, temperature, or level and things like that, oil level and things like that. So we capture those kind of data sets and then feed into the framework, and the different layers on that, the contextually, to analyze the data and present to the application layer. So customer need not build the application, we build the application already. So the customer can look at the data, access the application, and directly start seeing the data and the process that build around that. So when coming to the APM, APM is part of the asset performance data, and how do we visualize that, and how do we use that data to plan and execute different maintenance operations. And so the key supporting systems that required to comprehensively handle the asset performance based maintenance management is on the basic information about the asset, which comes under the asset lifecycle management or asset information specifications. So typically, it's all part of the asset management aspect of that. And then, after data analyzed and after data triggering, recommendation, prediction, and things like that, how do we carry forward that as part of the process in the shop floor, to give the maintenance team to have digital tools for them to properly go and do the maintenance activity and track it, and know the effectiveness of the maintenance activity and the history of the maintenance activity, that also feed the data back into the APM. So it's not just it's a combination of that, so all combined together, giving the process capability, data analysis, data based data driven maintenance operations, and leveraging the real live data from the system. So that's how we put together we leverage the framework and then put together the contextual to that. And we implement that. We have already implemented that as part of the Fogwing AOM solution, which is nothing but Fogwing asset operation management solution. This is a comprehensive solution which have integrated functional features from asset management standpoint, APM, performance management standpoint, in terms of capturing data and identifying the health parameters, detecting, anomaly on that, and predicting the upcoming, maintenance demands and things like that. And then following the demand of, the maintenance operation process with the help of the CMS system. It's all unified here together and hosted and available on the AWS infrastructure as per the framework itself. So you can see that, the basic cloud capability, on the AWS. On top of that, building IoT based interfaces connected to the machines, and collecting the data, processing the data, contextualizing the data and identifying different KPIs with the help of data intelligence layer, and then presenting it to the APM and even supporting to CMS and EM aspect of that. So this is how we comprehensively put together all the all the bells and whistles into the system as a system where customer can start quickly realizing start connecting to the assets and quickly realizing the data and process into that. So what we are leveraging in the AWS side of that, as part of the whole solution, we are using some of the key services, technology services available in the AWS to comprehensively collecting all this data. So we use the IoT site-wise to capture to build the connectivity between the asset and to the application standpoint, and capturing the data, processing at the edge level, as Kailash talked about the edge level processing and all, processing that at the edge level, especially data processing at the edge level, and then feeding the data into the cloud application so that the process can trigger based on the data. And the audience of the solution, or the user of the solution, who can leverage these data sets on the go by using mobile app and tablets, they can look at the data and then take action on that. Especially when asset intensive environment, it's very hard for the limited engineers to aware of every asset, every components, every parts availability, every different functionality. So it's easy for them to use that digital tools on hand to look at the data on the field, and then taking some recommended maintenance actions on that. On top of that, IoT connectivity, we also use the Lambda functions for processing the data, cleansing the data, aggregation, and things like that. And we use the AWS data lake, S3 based data lake, as an operational data lake where all the data consolidate together as a stage environment. And then from there, it's processed with the help of industrial AI layer, which is where the SageMaker, we leverage the SageMaker and Bedrock for the generative AI aspect to identify different predictions, or identifying different KPIs and things like that. And those KPIs are presented to the application layer on top of that. So that's what the user will use it. So abstracting the technology part of that, and then taking care of rapidly implementing the solution, and then allowing the end users like a maintenance operations team or asset management team to leverage the application from day one, rather than longer waiting period to start functioning quickly and rapidly. That's how we are using this of AWS services. So in terms of the functional feature standpoint, of course, it's a 3 different application unified together as a single data repository. So you don't need to maintain everything everywhere. So you can use a different audience standpoint. See, asset management is more focused towards managing the asset in master data, financial information, especially capex and opex, how the operational expenses are happening, and contract management in terms of if you outsource to somebody else to do the maintenance operations, or you are internally engaging with your own maintenance team to run it. So how the contractual management and all vendor contract relationship, and warranty management, and all those stuff are maintained in the asset management standpoint, which is more intended for asset managers who are responsible to manage multiple plant related asset and related capex and operational aspect of that. The APM is more on the field level engineers who get the access to the data, or the strategists who work on the maintenance operation, especially maintenance head or GM, to look at the data sets to identify how things are happening in the actual health of the asset, in terms of asset health parameters, in terms of connecting, understanding what kind of assets are, what kind of assets are available in the field, what are the down, and how things are happening, and even in the energy consumption standpoint, because energy consumption is one of the critical asset health parameter to understand the health or performance of the asset itself. The more long running assets might take more energy consumptions due to the parts and related challenges. Whereas the newest machines may not take that much more efficiently, energy efficient, and may perform very well. So the comparison of that could be done with the help of energy monitoring in the APM itself. And on the CMS is more practical, right? So no, okay, I got the data, I got the information about the health, and this particular missions need maintenance service on the next month or the following month. How do we schedule it? How do you plan and put together in the system so that the engineers can go and follow the procedures that we have been? Knowledge management in the maintenance field is the most challenging part. And how do we maintain this knowledge in a single repository system where the people can follow the practice, get the data, analyze the data, and then do the actions as per the prescriptive or predictable information? That is what the CMS part of that. So all combined together, customer can start leveraging together. So on the again, this is more detailed view on how this is, and especially enterprise asset management is more on AI generative AI driven model where different data sets are being looked at. I will show the demo quickly in terms to show the more detail. On the asset performance or CMS or both, either it's want a more condition based maintenance or asset performance based maintenance, or reliability based maintenance. All of them is driven by the data that we gather from the machines. So when the data coming from the machines, how do we connect to the machines? So how do we connect to the machines? So we fulfill that with the help of our own devices also to connect to the machines. Different machines we need a different data sets. Depends on the what parameter, health parameter that you wanted to monitor from that. What is a critical health parameter that you want to monitor, and how do we tap into the data to gather the data? Either it's the existing system that you are already collecting it, or you don't have that system and it is more of a legacy machines, and we need we need to fit the sensors to collect it. We fulfill that in that case on the operation side. On the performance monitoring standpoint, especially APM standpoint, after gathering the data, the key important thing is on the health. The health score, I think it helps to identify the score, and based on the frequency of the maintenance or frequency of the repair happening, and the between the time between the repair time is happening. So MTTR, MTBF playing a major role on that, and that required the capturing that information and processing it with the intelligence is very important. And also the health parameter can also be used to identify any anomaly and that abnormal activities or anything that we need to predict it, like what could be the next time this event could happen. So like that we need to detect it. So all of them part of the APM. I will quickly walk through that as well. We talked about the device, right? So one of the things Kailash also talked about the edge computing standpoint. How do we capture the data, process the data locally, especially on the compliance standpoint or emergency situation standpoint? How do we trigger different events based on the local events happening on the or the health parameters or health conditions happening at the machine level, especially on the safety standpoint. So we provided three different approach on different type of hardware or IoT edge device solutions, which could address a different contextual standpoint. If edge is not required, it's a simple asset which does not need edge kind of a capability, and we just need to quickly connect it that and then start reading the energy consumption, key parameters like a vibration, sound, temperature data from the asset. Then we could go with a simple IoT controller, so which are not edge, but they basically capture that the data from the sensor and then push it to the application, so that the application start detecting the prediction and all. So that's a simple device, easy self installation device that we can send it to customer, and they can just fix it and then start sending the data to the cloud, to the application. Second thing is on the edge server standpoint, it's a more of server capability which handle the process with inbuilt AI capability, like prediction models and all can be deployed into that, and that can take the data and process the data, analyze the data, identify the critical high sensitive data sets, health data sets, and then triggering indicating to the local indicators like LED indicators, add-on indicators, or sending that to the alarm and things like that, which handle like even connecting to the multiple assets and collecting the data in a single system that can process it locally at the factory level, which can be done in the edge servers. The edge and node combination is for the mass rollout, where a number of machines are there, and each and everything needs to be connected, and everything in sensing data should be collected. and then process it in the edge level, in the machine level, as well as at the centralized location within the factory floor. We can deploy the node and server model architecture, where the small mini sensors or mini controller unit connected to the locally, and then gather the data at the factory floor level as a single the gate where all of them processed, and then the data sent to the cloud for the digital access standpoint. So that's how we three different aspect of practically deploying the devices and capturing the information can be handled in that. Now, I will go to the application, quickly run through, how this is done, and I will show you the demo version of that, which with the pre-filled data sets, to give you the idea. But if you are interested to, do an elaborative detailed level of demo, then we are happy to do that. You can approach to AWS team, or you can approach us, and we can do that, as an elaborative session on the demo. So now let me go to the application and show it. Okay, so quickly, first thing, I wanted to start with the asset management standpoint, because that's where you start creating the data first, and then going and processing it. So you can see that this is a Fogwing enterprise asset management solution, and the dashboard itself, showing the overall comprehensive view of the asset and the asset operational process. You can see that in the number of assets, the total capital investment, operational expenses in this year, and total depreciation value over the period of this year. And you can also see that different operational expenses on a month-on-month basis, based on the maintenance activity, parts usage, resource costs that we have invested on top of the asset investment, as part of the regular maintenance or preventive maintenance or even predictable maintenance. It depends on what type of maintenance you are carrying forwarding. All the expenses are captured here to give that. This gives a asset manager a quick and easy view for them to understand what is happening in the system and how things are being spent, what is budgeted for that, and then what is the actual things are happening. And also, it gives a more picture on on how the at least assets are utilized, and different categories on the utilization in terms of the plant level, in terms of the cost level, life cycle time. And more important is to understand which assets are more expensive, means more effort required to maintain it on the basis, and what is the cost involved on that, right? So you can see that top 10 expensive assets, which are based on the cost of operational cost, and how this is being done, and then pay attention to the top one to to reduce it. That's how the operational cost can be mitigated and reduced. By going into asset, you just give a asset a view. In the asset itself, each individual assets, they can validate it. Example, I can go to this particular asset, I can see the asset basic information, then I can look at the asset maintenance activities that have been done, reliability score in terms of what is the health of this particular asset, what is it availability duration for each month on month, what is the fault most frequent failure happens in the machines. In this case, power outage is the most frequent failure, as well as the expensive parts that being used in that. So this gives the reliability aspect of that, if on the asset, and that gives the more information to that. In terms of the parts that being used, the IoT metering data, and more important, individual asset financial, not just the dashboard to show that financial of your overall plant asset operations, but also individual asset operations. What is that what is that its operational expenses, how the cost has been distributed on the individual assets, and then the depreciation values and spending things and all. So based on that, and also look at the specifications. You can also have this, you can maintain all the asset specification in a single repository to manage that. So all your specification files can be maintained and can be easily accessible by the users. So this is just a glimpse of how the quickly just within the two key functional areas, the asset manager can quickly view the overall asset operational aspect of that with the high level view on that. Let's go to the APM side of that, right? So in the APM side of that is more intended for the maintenance engineers, maintenance manager, or the performance in responsible team, who operational team, who are responsible for performance handling. So in the APM side, it's all about data, right? It's all about data and health information from the machines, so or the assets. So, but at the same time, we should know that what is the overall perspective of that, right? So this dashboards gives the overall asset, and then the asset down, what is it down right now, and how many assets are available, and what is the health score of that, which are assets are very low health score, which we need to pay more attention to the maintenance operations and things like that. And also, in terms of the total downtime of this period. And moreover, it's also giving the energy consumption on the overall, operational standpoint. Especially plant managers can see that at the plant level, maintenance head can see that at the particular plant level overall energy consumption. That includes a different type of energy that they are using in the plant level, either solar energy, gas energy, and things like that. This can be completely configurable. All the configurations can be done in the system implementation standpoint, and it's easy to configure it. And basically, you need to feed the data so that when the configuration is done, the data coming from the assets, the combination of the configuration data and the asset combined together with the help of intelligence, arriving their values. Not only the consumption of the data, but also about the CO2 level. We calculate even the CO2 level to say sustainable commitment standpoint. How much the plant level emissions are happening on a month-on-month basis. Now, if you go further down on individual assets, you can see all the list of assets that we have right now in the particular shop floor, and then that individual details on a day-to-day basis. This is the real-time data and today's data, and where you can see this basic asset information, and you also see that asset process parameters. Very important. This is the health parameters. So in this asset particular case, you can see that power consumption, vibration level, and the oil level of that. So if you look at this, these data are coming really from the system, and understand, how these data are, put together in the asset view level for a current status. This is for the current status as of now. What is the current data, health parameters that I can monitor here? And even if you go into one particular, power, so you can see, particular time window, how much the consumption is there. And then, what is that, overall time. You can also download this and use it as a references, but later point and all. So you can individually track each and every health parameters into this on the current live data standpoint. And in the particular asset itself, you can see the consumption of that. In this particular asset is using gas in energy to run through. So you can see that peak gas usage time on a particular window. And also you can see the downtime. There is no downtime right now recorded here, but typically when you have a downtime, it indicates the downtime. Even in the top also, it will indicate the downtime. So understanding live scenario, what is in my current situation. And in terms of even sensors, the sensors are very connected to that, right? Whether the sensors are really connected or not, is that the data is accurate or not. That also we bring that here as part of the data sets. You can configure your own hardware device. We give you the template. You need to follow that template and then feed the data to the system. Or you can use our hardware devices, which are pre-built into that, and that brings the data, and that also gives you indication whether the sensors are growing. If in case any issues with the sensors reading data, or sensor connectivity issue or something like that, it will indicate here as that there is an issue with the sensor log itself. So we don't need to rely on this data set, and we need to fix the problem. You can also go back to the previous days and look at the previous days on how these days are fulfilled. So this gives you the quick view of the data, the raw data, the data standpoint. But if you go into intelligence page, which similar page, but it gives you the more trend aspect of that, because trend is very important to understand the health, and which brings the health score also here, so that you can quickly look at the health score. You can look at the availability over the month-on-month basis, and also you can look at the each and every parameter, that's a process parameter, how the process parameter is over the period, and what is the consumption on an average basis. And is there anything anomaly detected in the previous period? So, and also this, I will show you how to trigger the work order based on the anomaly, and that's part of the configuration. But here, it's more of visually seeing that and checking with that. And in terms of the energy rate consumption over the period of time, so the trend of that particular period and individual assets, we can go through that and analyze it and understand it. But that's not necessarily you need to always sit in front of the monitor to see this, because there is a configuration that helps you to automatically detecting the anomaly, and then automatically triggering a work order for the engineers to go and look at the issue. Either it could be a simple inspection, or it could be a complex, immediate attention is required. Depends on the volume of that, so you can define it. So now, in terms of the energy monitoring, it gives more plant level performance. So you can see here, the entire plant level energy consumption. The top section, you can select the plant. Right now I have only one plant, so you can have multiple plant. If you are the and multi-plant administrator, you can see that all the plant here. Or if you are belongs to only one plant management, by default it will bring that to your plant, and then it shows you the all the energy data sets here, in terms of overall energy and individual type of energy use cases that you have configured in the system, and it is dynamically loading pages based on your configuration. Either you are using solar or hydrogen, or or windmill based energy. So you all of them will bring that here, and it will show you the data sets related to the particular energy type of consumption. So where do we do that, right? So you go to the settings page. If you go to settings page, you declare the plant, you declare the asset category, and then you have to declare the monitoring aspect of that. Now, in this case, you can see here, the energy source is declared. It's a simple energy source declaration with the cost associated with that. And then either meter based or delta data that you are gathering from the machines. And then you can configure this. So I have already pre-configured this. Similarly, how do we connect to the IoT data, right? So to connect to the IoT, we need IoT configurations, right? That also, we connected with this. So it brings you that it works with a site core through API calls, and it brings the list of connected devices, and then you can map the devices to the assets. So you have a devices configured at the asset level, and let's take this particular device. You can see that maybe this filtration station. You can see that this particular device is connected, and this particular device has a list of sensor attributes which are bringing in, and these attributes are mapped to the particular asset in the mapping. How do you map it? You go to the process parameter, and you go to the process parameter, and then you can declare the mapping by selecting the asset, which asset you want to map it, and then which particular device data that you want to map it, and you just select the sensor keys into that. So when you map it, automatically the data will fulfill into the process parameters, and then the process parameter shown in the monitoring center part. So we made it as a configurable, more configuration rather than more writing a code and building it. So it is easy for our customer to realize this solution rapidly, faster. Quickly go through the maintenance standpoint. The CMS application. CMS application gives more from the maintenance aspect of that. This is our CMS application, where you can see all the tasks and things. This is for maintenance people. So maintenance people on day-to-day, they will look at the data and look at the work orders. Then they have to attend it. So you can see that some of them are preventive, triggered by system, and some of them are on demand, requested by the user, and it can be captured, and it can be assigned to people. So let's take, I want to assign this automatically. You can assign to the individual, and then let them go and look at the issue. So this bring the process, and what they have to do that, they go to the, when they go logging into the engineer, logging into the system, they see that what our work order is assigned to them, and then they can carry forward this. For example, I have already working on this particular work order, where you can see that all the action notes and things like that. But more important, I want to show you how to configure the alert, right? So go to the assets, go to the assets. In the assets, if you want to configure it, so go to the particular asset, view. So all data are same, similar data sets. You need to declare the metering, and then you need to declare the IoT based metering. So this is where you connected with the IoT data. So now in this case, you can see that I can see that power, vibration, and then other data sets. Now I can choose it based on that. Okay, if a vibration is greater than, let's take 100, right? So you can create a work order, check inspection. So you can just simply create a check inspection, check the vibration, and you can declare it type of priority. Maybe this is not a high priority, it's just an inspection. So I just put it as a medium type work order. So, and then inspection work order. So you can declare this, and once you declare it, whenever the data are exceeding that particular limit and anomaly detected, and automatically it's triggered the work order to the particular engineer or manager, so they can look at that as triggered part of that. So this itself is a simple mechanism to do that. You can also do more automated way as well in the system. So all can be handled. So combination of that, you can see the same asset information here. You can see the same asset information here as well. I'm sorry, if you can see that same asset information here as well, you can see the same asset information in this application as well. So all of them is in a single unified data set. So all the data are in the common area. So you any different different stakeholders within the maintenance operation or asset operation, they can like take a look at the data sets and all. Back to the presentation quickly. So what value you get it? So pre-built A1 solution, quick and easy and faster way to implement the solution. Available on the customer cloud. So we also provide it in the customer's AWS cloud and maintained by us. So customer need not worry about how do they manage this large technology landscape. So we help the customer to maintain this as administration done by our team and ready to deploy it, and quick and easy way to capture the data in the centralized data lake within the organization, so that you can use this data even for other purpose, like feeding into your integration system or feeding into your BI system and overall financial data set system. You can take this data and use it. And so we build this landscape, and the landscape is not just for AOM purpose, but also for the other data sets that you can use it. And role-based access, and then industry grade devices that we provide along with that. So all of them are comprehensive way of solving the problem for our customers, and customer get all of them together from along with the AWS services. How do we implement it? We quickly implement it on a three space. One is preparation phase. We do the site visit to analyze it, analyze the machine types and the different type of devices that required to connect to that infrastructure. And then we prepare the connectivity part, pre-configuring that IoT mapping, environment settings, all of them together. And then we ship the devices, or we help them to configure the devices on the floor. And then we train the people, your engineers and maintenance team and asset management team, to train the team to start using the system on a day one in day basis, and ongoing basis. We help them on ongoing support standpoint, also in terms of technically ongoing training standpoint, because we continuously releasing the solutions, we continuously upgrading the software, we continuously releasing it to the environment, even customer environment. So customer need not worry about the new functional features, and we provide as part of the training process itself. It's ongoing training, ongoing support, and continuous releases, which enhance the customer to rapidly use this technology, and quick and easy, faster way to get into the actual practice of asset performance management into that. We are a ISO company. We strictly follow the security standards, and we are a key partner for the AWS in terms of this particular industrial solutions standpoint. And we are specialized on the industrial software solutions aspect of that. That's all. Over to you, Prasad.
Thank you, Mr. Kailash and Mr. Hariharan, for that informative and insightful session. Now we would like to open the floor for the questions, and we'll be moving on to the Q&A sessions now. So if the attendees have any question, feel free to ask them in the Q&A or the chat box, and we will be happy to answer them. I'll take on with the first question here. So how long it takes to implement APM in AWS is the first question.
Okay, it depends on the approach. I think as Mr. Kailash talked about, either build versus buy. So it depends on the approach. I think build is depends on your manufacturing landscape. Depends on what kind of machineries you have, and what kind of internal capability that you have, or services capability you have, or the partner that you are engaging with. And what is that level of that implementation that you want to do? That do you want to build like asset management, or you want to go into APM core data visualization standpoint, and what kind of key point that you want to address it? So there's no standard. It depends on what you want to put it as a scope of that, and how do you want to approach it. It's based on that. In terms of the buy versus in this case for us we quickly ramping into that. So the very first thing we give the customer is the basic asset information and configuration, which is more configuration before even we go and connect the machines and getting the data from the machine standpoint. So we quickly do that. Maybe 3 weeks period. We can onboard the customer and quickly load the customer's existing data sets into the application. And then we can do the because that way customer can start looking at the data in the system, where asset data or maintenance operation also can be done quickly. So that we do that EAM CM initially, within the 3 weeks, so that the customer can realize that so digitalization coming immediately. But on the implementation of the asset connectivity to start gathering the data on APM, it's probably take depends on the size. Typically it takes 8 weeks to based on the size of the organization and number of plants, and we need to do that. Maybe the 4 or 5 months and all. So depends on the size and things like that. However, we have a structured approach. We can help the customer to quickly do that faster way to realize that implementation and ongoing basis is improvement, because it's APM is not like one solution that will just come and fit into that. It needs to be ongoing practice. So yeah, apart from capturing the data, how effectively you are utilizing the data with the help of the system, and then how you are practicing the maintenance operation is also the key value of the delivery. So combine together all of them, it may vary from 3 to 6 months period, depends on how rapidly customer adapting the solution into that.
I totally agree with what Hari mentioned, right? It totally depend on, see, there are a lot of factors, right? First, as Hari mentioned, you need to decide whether it is going to be buy or it is going to be build. So that's a primary decision that you need to make. Second would be, once you decided to say build or buy, right? There are other dependencies like, see, ultimately it's all about data-driven implementation, right? So how are your assets ready? Are the data is available, right? Or do you need to have an additional sensorization? So all those factors would come in. Actually, where are you in your maturity, right? APM maturity. So that will ultimately decide it is going to take, say, 4 weeks, 4 months. Again, actually, it will also depend on, as Hari mentioned, right? Because APM gives you a broad capabilities in terms of maintenance, reliability, safety, asset integrity, right? What you want to achieve. So depending on your objective, what you want to achieve, actually, you can try to quickly get started by just say implementing in predictive maintenance or condition-based monitoring. So depending on what you require, it will really depend on those factors.
Okay.
Yeah.
Okay. There is one more question. Do this software provide information regarding asset prediction of time to failure? Note this is a part of prognosis.
Yeah. So there is a inbuilt model that we built on that to detect anomaly. So based on the based on abnormality, the prediction is happening. So example, there is a abnormality happening, first history, first event, and that based on the abnormal, it triggered the maintenance operation, and that maintenance operation executed in a period of that, and that impacted the health of that. The accumulation of that repeated event is adding into the prediction, more accurate prediction into that. So how frequently this event is happening, the more accuracy will happen on the prediction side of that. So what we can do, historic data, we take the historic data, we feed into the system, and then based on the historic data, based on the previous maintenance operation that you would have, even manually you would have done it, we could import the data into the history, so that using the data sets we could identify that when the next probability of prediction, and then the more accurate data, more data you have, the more accuracy will come on the prediction side. Initially the prediction side will be very limited. As you are practicing more and more, the practice makes it very easy for you. The more and more you are practicing following that, and that will feed into that. Not only that, the data that you're capturing, after as part of the maintenance operation, your engineer going and fixing that issue, and what they are entering into the system as part of their findings in the summary of the issues that they have solved it, that also feed into the data sets back into that, because we have summary models, so which will feed data back into that. Using that summary also, we predict it and even give a prescriptive instructions on what could be the issue and what is the previous fix that you have done by the previous engineer. So you don't need to maintain the same knowledge with one person. The knowledge will carry by the system itself as part of the recommendation engine within the application. So its prediction is pretty much possible, but it needs a lot of data. So we need to have the data first to do that prediction. The accuracy will increase as such as how much data we are consolidating together in the system.
Yeah, and actually, as Hari mentioned, right? So you need to have an good AI will only be able to give you those predictions based on the data, how accurate or good data you have, right? And the amount of training, amount of experience that your model gets it. But once it has been able to do these things for quite some time, right? It's able to really predict, right, when your asset is going to fail. But actually it can go beyond, right? It can actually also tell you about the remaining useful life, right? How long the asset is going to run, right? So all those prediction can be done, but depending on you have a right amount of data, you actually train the model with your past maintenance even history. Those things are very, very critical. And this is one of the prominent features where actually APM is really helping a lot to customers, because of these predictions, they are able to really optimize this maintenance activity, which helps in reducing maintenance cost. Plus, it helps in reducing spare part inventory. So it's actually one of the key features that is being addressed by APM.
Okay.
Yeah.
Okay. There is one more question, which is on which statistical principle that you adopted in the algorithm? Is I think the same attached to the first question only.
Yeah, so there are different statistical algorithms, so you need to apply it. So what we do that, once we basically not every algorithm will work for every customer and their data sets. That's very important. So what we do is, we have different models built behind that, and it depends on the customer and then data sets. What we do when we get the data first from the customer, we have the as part of the configuration and rolling out, we apply that different data sets models, different algorithm we apply to that, and then see that which one giving a better results to that. Of course, there is a customer involvement in this on that, and to identify whether that is a accuracy on that, or in terms of the previous history and things like that. So there is no single one algorithm that works for all. So it depends on the data sets and what data you have and what kind of value that you're bringing in, and then how which model is a better fit for that. So what happens, when we, as part of the configuration, when we deploy the model into that particular account, for your account especially, we identify that to do this data analysis first as part of the outside of the system, as part of the implementation process, to detect the right amount, right algorithm, and then deploy it. We even use a simple, even we have seen that, with the Gen AI nowadays, we don't need to, use the existing algorithm directly. We can even use the Gen AI to do some of the predictions. So we have seen that, Gen AI also giving some better prediction model. So if you're using Bedrock, and then using Cloud and other things, so we can even feed the data into that. So Bedrock, Gen AI itself is one of the way that we can even use it and predicting it. So it depends on it. So there is no single approach that fit for all. So we need to design it based on the data and then the algorithm that works for the particular data sets.
Okay. Okay. I think I hope that answers the question here. Moving on to the next question here. Can SCADA device data connected to this APM solution directly?
Yeah, as long as you can take the SCADA data and historic data, and you can feed the data into the system on the or even regular basis. You want to feed the data into the system using this format that's supported by the system. So as long as you are processing the data and then feeding the data into the system, which is possible, but you need to be clear on how the data is coming, because it's all about real-time data. So SCADA is more of staging. So it's not fully recommended, but that's why you have the historic data. We can really take the data and use it. And you can also even stage it and then send it, but it's very important sending a real-time data rather than staging data, so that the data will accuracy. End of the day, the maintenance engineer need a real-time data. So and they want to go and see that in real-time basis. So they don't want to see that historic data, right? So it depends on that. So how what kind of SCADA that implementation you have done it, and how quickly we can take the data to the SCADA. From there, how we can push it in there. But to answer simple answer, yes, it's possible. But is it recommended? Not really.
Okay. Okay. I think that's all the question that we have today here. Thank you everyone for joining this session here. The recorded session will be available in our YouTube channel, and you can always check that out. Thank you again for joining this session here. I hope it give you all the required insight and information about the asset performance management here.
Thank you, everyone. And Kailash, thank you so much for joining us and presenting fantastic session on the AWS side of APM. And hope everything is helpful to our audience and followers. Thank you so much.
Thank you, everyone. Thank you, Hari and Prasad, for your time.
Thank you, Kailash.
Thank you.